Lesson 31B, tables with proportional relationships. So we're continuing on with this idea of all of these things that make a proportional relationship, and we're focusing on completing and creating tables, finding unit rates, and equations today. So background knowledge. We know what equivalent ratios are, right? Those are a comparison of two numbers, y over x, for example, 1/4, that is equivalent to a bunch of other ratios or fractions that all reduce down to the same number, like these three. They all reduce down to 1/4, right? I want you on your paper, right next to that, I left you space, write 4 more. 4 more equivalent ratios that are the same as those. They reduce down to the same ratio. Good, I'm seeing people write 4 over 16. Good, 5 over 20, 6 over 24, and 7 over 28. And some of you kept going further than that. That's fine. These are all equivalent because they all reduce down to this ratio. Do you agree? So, you see how you have your table there? There's some missing values. They are values that were all coming from these ratios. This is y over x, y over x, y over x. Go ahead and fill in the rest of that table. This 12 over 3 came from this ratio. 12 over 3. 3 over 12. Sorry, I said it upside down. 3 over 12. This is 2 over 8. This is 1 over 4. Fill in the rest of that table. Next would be 5 over 20, then 7 over 28, 10 over, and 12 over. Good. So table values, if you read them as pairs of numbers, the x and the y together, that is a ratio. And across the table, they're all equivalent, and that's why we've been able to find constants from them, right? Equivalent ratios are when they all reduce down to the same number, and these table values all reduce down to 1 over 4. So we're going to take that idea today and complete tables to combine everything that we've done so far, like this problem here. We take that table, we take that graph, and we can list out all the equivalent ratios to find our constant, which in this case is k equals what, everyone? 4, good, which means our equation is what? What is it? The equation of the line, of the proportional relationship. Not y equals 4x, but d equals 4h. Good. So look at number 1 on your notes. I gave you this table here that is representing Fred selling 4 items for $84 and then some other number of items. The first thing you're going to do is find the unit rate, which is from this given rate. If he sells 4 items for $84, I want to find the unit rate, which is y over x, 84 divided by 4. What would that be? 21. $21 per item. Now, if you haven't figured this out yet, a unit rate, this $21 per item means it's $21 for 1 item. Unit rate is for 1 unit. So in your table, see where it says 1 item? How much does it cost for 1 item? We just found that. You were going to write 21 here. Okay, so unit rate is really important because you need to put that in your table, and it's very useful because now that you know the unit rate, you can fill in the rest of that table. What's the equation once now that we know what k is? Because unit rate is k, right? Carlos? Good. Y equals 21x. So I know 21 is the cost for 1 item. How much would the cost for 2 items be? Good. This would be 42. How much would it cost for 10 items if one item is $21? What is it? 210, good. If it costs $21 for one, how much would it cost for 100? Yes. Good, this would be 2,100. So you can use the unit rate to find how much it costs for any other number of items, or you can use this equation. For 2 items, 2 is the number of items x, right? So I'm going to take this 2 and plug it into my equation. Plug it into my equation where x is. So 21 times 2 will give me y, which goes here, which is 42. How much would it cost for 10, which is an x value? I'm going to plug it into x. 21 times 10 would be 210. 100 times 21 would be 2,100. So there's several different ways you can finish filling out this table. Use the unit rate and just figure it out, or you can plug it into the equation. They gave you x values for items, so you plug that into where x is in your equation. Make sense? So now I'm asking, does this table represent a proportional relationship? What do you think? Yeah, obviously yes, because we used k to fill out the table, right? So of course it's going to be proportional. All the ratios are equivalent. And then using the equation now, I want to know how much it costs for 40 items. 40 items. This is a number of items, which is which variable, x or y? Number of items. Is that x or y? That's x. So if I use my equation, which is y equals 21x, I'm going to plug this 40 into x. Y equals 21 times 40. How much would that cost, Adrian? $840. Good. Now, a way you can check your answer to make sure it makes sense, because let's say you got 5,000. Obviously, that's not going to be correct, right? Because it sounds like a ridiculous amount of money for 40 items. But here's a way that you can quickly check. The number 40 is between 10 and 100, right? If I were to add another table value, 40 would go right here, right? So since 40 is between 10 and 100, my cost better be between 210 and 2,100, right? And also, you notice that 40 is closer to 10, so your costs better be closer to 210. So it's in between and closer. So our answer, 840, is it successfully between 210 and 2,100? Yeah, and is it closer to 210? Yeah, it's a lot further away from 2,100. So I know that my answer makes sense. If you got something like 5,000, then you probably just multiplied wrong, right? Your answer doesn't make sense. Let's look at number 2. Macy's car traveled 420 miles with 12 gallons of gas. So this is already in my table, right here. I'm going to use this given rate to find the unit rate. So you're just dividing, right? Divide to find unit rate. So 420 divided by 12. What is it, Scott?
35.
35 what?
35 miles.
Good, 35 miles per gallon. Now that unit rate is also our K. So we can find in our equation, right? What would our equation be if K is 35?
It would be D equals 35G.
Excellent. We want it to be miles per gallon, so that's D over G. D equals 35G. So we know 1 gallon gives us 35, so I can put that in my table. And now I'm going to use my what I know here to fill in the rest of it. You could do this. D over G, right? That's what we know. And we also know our unit rate. D is 35, gallons is 1. And the next value in the table is 3 gallons. So that's 3 on the bottom. And I want to know how many miles. What does this look like to you? Ratio equals ratio. What's that called? Solving what? Yeah, a proportion. This is essentially solving a proportion, which is what a table is, really. It's a list of equivalent ratios, which is what a proportion is. It's equivalent ratios. So we can solve this by doing that. 1 times 3 gives me 3. 35 times 3 gives me 105. So I know that this table value is 105. The next table value is 20, and that's gallons. So I know gallons is going to go here. So this one would be 1 times 20 is 20. So 35 times 20 is what? Carlos? Good, 700. So you can do this with a proportion, you can use the unit rate, or you can use the equations. Here's the equations. 3 is the number of gallons, so I'm going to plug that 3 into gallons, where G is, which looks like this, and you get your answer of 105. Or 20 is the number of gallons, so you plug that into G, and you get 700. And then 25 is the number of gallons, so you plug it into G, and you get D is 875. Lots of ways to fill in this table. And again, you want to check your answer when it asks you for a bigger number, which is the last problem here. So is this proportional relationship? Obviously yes, because we used K to fill it out. All the ratios are equivalent. And I want to know how many gallons it would take to travel 525 miles. So careful here. This 525 miles, is that G or D? Look at your table. Look at those labels. Is miles G or D? It's D. So when I use my equation, I want to plug in this 525 into D. So your work here is going to look like 525 equals 35G. Now we've done over 1,000 of these equations over the year. I know you know how to solve for G. How do we isolate G? How do I solve for G? Carlos? Divide both sides by 35. Tell me how many gallons that is. The most important thing here is to be careful. They gave you miles. Don't go on autopilot and plug it into G. Miles is D. Plug it into your D. Substitute 525 for D and then solve for G the way you know how. Scott, what is the answer?
I'm not sure if I'm right, but I got 15 gallons.
You are correct. 15 gallons. And again, I was starting to talk about this before. Checking your answer. 525 is between 420 and 700, right? So your answer of gallons better be between which numbers? 12 and 20. Is 15 between there? Yes. So our answer makes sense. Let's look at number 3. Go ahead and try to start this one on your own, and then we will go over it. Okay, you finished this with your shoulder partner. And the very first step, like you told me, was to find unit rate. They gave us the rate for 34 text messages in 4 minutes. So how many messages can you send in 1 minute, Grace? 8.5. Good. Dividing that gives you 8.5. So you can put that in your table. What would your equation be? Good. Y equals 8.5x. They gave us x and y this time, so you can use x and y. Now that we have the unit rate, The rest of that table should be easy. The next number they give us is 17. Is 17 a number of messages or a number of minutes? It's messages. That's y. So you need to plug 17 into y. So your equation there should look like 17 equals 8.5x. And then solve for x by dividing both sides. How many minutes is that? You should get 2 minutes. The next table value is 20. 20 is an x value. That's a number of minutes. So you need to plug it into x. So that looks like y equals 8.5 times 20. So that you can get y and put it in there. And what does y equal? That equals 170 messages. Same with the number 60. 60 is a number of minutes. So 8.5 times 60, what does y equal? Yeah.
510 messages.
510 messages. Okay. What is the constant of proportionality? This should be really easy. Everybody. Excellent. K equals 8.5. Now this last question, you could have used the equation if there were 0 messages. Messages was y. So I'm going to plug in that here. And then 8.5x. Divide both sides by 8.5. 0 divided by anything. You split up a cookie to 0. Split up 0 cookies to 8.5 people. How many cookies did they get? 0. You started with 0, right? Or you can just use common sense. If you didn't send any messages, how much time does that take you? 0 minutes. Make sense? All right. Good job. Let's look at number 4. This is pieces of candy for how much money it costs. So Sandy bought 5 pieces of candy for $1.15. The first thing you're going to do again is find unit rate. How much does it cost for 1 piece of candy? Okay, so you've done this whole problem with your partner. The first step is to find unit rate. What is the unit rate? Grace? 0.23 is what that's as a unit rate I need a label. Good. 23 cents per piece of candy. So that means my equation is going to use my k equals 0.23. What is my equation? Careful, the variables are not x and y this time. Emilio.
C equals 0.23 cents.
Good. C equals 0.23 p. We want it to be cost per candy. So y over x, that would be c over p. So we have c equals 23 cents p. Now using that, I'm going to fill out the rest of my table. For 2 pieces of candy, it would cost 46 cents. For 20 pieces of candy, it would cost, times 20 would be $4.60. If I have $13.80, how many pieces of candy can I buy? That last one gives you a cost. So I need to plug that into the C part of my equation. And then solve for P. Good. You can buy 60 pieces of candy for $13.80. What's the constant?
23 cents.
0.23. Careful, it's not just 23. 0.23. And then another common sense question again. If you didn't buy any candy, how much does that cost? $0. If you plugged it into your equation, you'll get the same answer, which would be C equals 0.23 times 0. Anything times 0 is 0, so C equals 0. Okay? Let's do one more. This is Amy walking 2 miles in half an hour. I need to know the unit rate, and then filling in the rest of the table and answering those questions. All right, let's go over this one. First things first, find unit rate. They gave us this rate, so I'm going to use it to find unit rate. Unit rate would be miles per hour, right? Miles per hour. So I have to divide with the m on top. That's 2 divided by 1/2. 2 divided by 1/2, which multiplied by the reciprocal would be 2 times 2. What's 2 times 2? 4. This 4 is per hour, so this 4 goes where 1 hour is. 4 miles per hour is my unit rate. 4 miles for 1 hour. Now that I have k equals 4, what's my equation? Using m and h. Grace. M equals 4h. Now it should be pretty easy to fill out the rest of the table. The first one is 0. You can either use common sense and think, if I spent 0 hours walking, how far did I go? 0. Or in your equation, m equals 4 times 0, which would be what? 0. Three-fourths. If I spend 3/4 of an hour walking, that will be times 4 miles per hour. How far did I go? 3 miles. This last one, they gave us a miles number, so I need to plug that into m and divide both sides by 4. How many hours did it take to walk 96 miles? This would be 24 hours. Okay, I saw most of you filled out your table correctly. Those of you who didn't, you divided it upside down. Remember, it's miles per hour that you want, so it's 2 divided by 1/2. K equals 4, and the ordered pair 1, 4 in your table, which would be this right here, 1, 4. Why is that important? Why is that so significant? Why do I care about 1, 4? What does that mean? What does that give us? What's it called? Exactly. This 1, 4 gives us the constant of proportionality. So on your graph, if we were to graph this 1, 4 is where you would find the k. Because this 1, 4 from the table, this 4 is a constant. Okay? Any questions about today's lesson? All right, that's it for today then. Number 1, would you please share first? What did you learn today? Ready? Share.
Okay.